Yes, welcome students. I am Dr. Jabaj coming to you teach again. In the previous cases, we studied about what is a planar graph. Planar graph is nothing but uh, the one edge will not intersect the other edge in a graph except the vertex. The vertex, the edges can intersect, but one edge will not intersect the other edges, and that is what we call it as planar graph. I give you an example. Also, Jordan curve theorem, because Jordan curve theorem and this planar graph, the two ideas we are going to use in this particular theorem, we are going to discuss today. So Jordan theorem says that if J is a closed curve, then any interior point and exterior point cannot be joined without intersection, and that's what Jordan curve theorem says. Or we can say that the interior point and the exterior point intersect by the Jordan closed curve theorem says. Now look at this uh, picture here. What I need is that um, wait, okay, what I need is that now I am taking K5. You know what is a K5? Am I correct? It is consists of four vertices. All the vertices were connected by edges. Okay, so is that possible that K5 can be connected each and every vertex by non-intersecting edges? That's what our aim here. Okay, I mean whether K5 is a planar or not. Planar, exactly. Planar is a planar. Is that a planar? Now, what is your justification for that? Is it possible that the edges of each and every vertexes cannot intersect? Is that possibility? So let me take prove that. Okay, right. This is what K5 planar. We know that what is K5 graph is a complete simple graph consists of 5 vertices. I am one vertex. I am taking as V1. This is V2, and then I am taking here as V5. Okay, sorry, V3. Okay, no problem. V3 I am taking here. Now, what I am doing now, I have to make a edges between the two vertices. Okay, so I will do that now. I can join from here to here. I can join from here to here. I can join from here to here. I can join from here to this vertex to this vertex. I can join this vertex to this vertex. I can join this vertex and this vertex. Okay, so all the vertices were connected to one another. Is it correct or not? Yes, but I have to connect this vertex, and this vertex without intersecting this. And I have to connect this vertex and this vertex by an edge without cutting the other edges. Okay, now look at this. This is what looking like a Jordan curve. We can take this as a Jordan curve. right. These are the intersecting. These are the, we can say that edges. We can join this. Okay. Now, how can we join this vertex and this vertex? Okay. And then left out edges are joining this and this. Okay. Right. Now suppose I am joining this vertex and this vertex like this, okay, and by taking this an external vertices. Now again I have to join this and this, okay, this and this I have to join. If I join like this, what take place? Here is the intersection. Am I correct? This is an intersection. So if we take this as a planar graph, then there is a contradiction because the two edges joining V1 and V5 and V4 and V2 are intersecting one another. Okay, therefore what we understand is that K5 is a planar or non-planar. K5 is a non-planar. It's a very easy proof. Am I correct? Planar. Linear. Planar. Now very interesting. Am I correct? So this is the way we can prove that K5, a complete, simple, complete graph, which consists of 5 vertices and 5 edges, not 5 edges, we have to connect all the vertices by the edges, is a non-coplanar. Non-coplanar meaning is that we cannot connect two vertices without intersecting the edges. That's what we proved. So K5 is non-coplanar. Okay. Now another important term is about now K33. Now another one is that K33 bipartite graph. Is this planar? Is this a planar? Okay, this is another theorem. Okay, is this a planar? The similar way as we did previously, like this, it is possible to prove that whether it's a planar or not. We can planar or not. Okay, I will prove now, but the time is very short because the recording time is only for 15 minutes, a free recording system. Now let me join that picture now. Okay, so now I am taking this is one vertex, this is another vertex, this is third vertex, this is a fourth vertex, this is a fifth vertex, and this is a sixth vertex, I suppose. Okay, right. Now what can I do? I can join this vertex and this vertex. I can join this vertex with this vertex. I can join this vertex and this vertex by the edge. I can join this vertex and I can join these two vertices. I can join these two vertices. Okay. Now what is remains here is that this vertex should be connected to this vertex. Similarly, this vertex should be connected to this vertex. But is that possible? Is that impossible? Now let I join this vertex to this vertex. No, impossible. There is a intersection here. Okay, so definitely it is impossible. It is impossible. Am I correct? So it is impossible. Now let me uh, do join this y. If I do this y, okay, very nice looking, and we achieved something, but it is not the case. Okay, what take place? This and this we have to join without intersecting other edges. Okay, without intersecting other edges we have to join. So I cannot join this and this. It is impossible. There's no edge which does not intersect and join here. We cannot draw this from here to here. Is that possible? No, it is intersecting. Okay, so it is impossible to do that. Now what can we do then? Oh, it is impossible. Am I correct? I will take this out. Now if I take let me take this way, it's impossible. Suppose I take this way. Oh my god, and again there is a problem here. The intersecting take place. Am I correct? So K33 is planar or not? It is not a planar. Am I correct? Yes, it is a non-planar. Okay. So K3 comma 3 is non-coplanar. Okay, this is what we understand. That's what we understand here. So, my dear students, in this small piece of time, within 14 minutes, I have taught you the two theorems. K5 is a planar or non-planar. We proved that it is non-planar. K33 is a planar or non-planar. It is also a non-planar. Okay, so with that, we are coming to the end of this particular session. In the next session, I will come within another theorems in discrete mathematics. Okay, thank you very much. Thank you.